we are live. So once more, hello everybody, and welcome to IBM Developer Meetup. My name is Marek. I've been here a couple times before, and but for those who don't know me, I am a developer advocate, and I will be your host for today. So thank you very much for joining us today, and a little bit of the explanation what we are doing here. So first of all, IBM Developer, we are a group of developer advocates doing mostly now webinars and virtual events. But from time to time, we are also running in-person events, and I hope we get back to those as soon as possible. I am a part of the group that is based in North America. Specifically, I am out of San Francisco Bay Area. And we are running various events as IBM developers. So we run cloud native development, serverless, containers, machine learning, everything AI, IoT and edge, mobile backends as a service, software as a service, blockchain, etc. Name it on the cloud, we have it. And we are now directing ourselves a little bit towards the hybrid cloud as well. So you will have a lot of experience and exposure also on our channel for hybrid cloud. We will speak about why containers. Then we will do some lab. And I think the Bradston labs are going to be there. I will talk about a little bit about Kubernetes, why Kubernetes, and we'll do some hands-on Kubernetes on OpenShift, which is the flavor of Kubernetes, and I will explain how it works and so on. So I think I will stop the presentation, and we can do some little of fun trying a poll. So let's try to run second poll. Are you new to containers? And this is the second poll we would like to share with you. And I am not new to containers. Let me just respond over here. And I am here just for OpenShift. Yeah, this is my answer. So please feel free to try to answer to the poll on the bottom of the page. And I am passing over the presentation to Bradston, and I'm closing my my screen, so Bradston can kind of bring up his if it's. So let me focus there. I will make it big. Yay. Can I do it?
It's good. Thank you, Marek. Hey, everybody. As Marek said, my name is Bradston Henry. I am a developer advocate at IBM. I'm super duper excited to be here today. I guess I'll give a really brief introduction for myself. Yes, I'm from Baton Rouge. I have 7+ years experience. But yeah, my background is gaming. I've worked in enterprise setting. I've worked in startup setting. I have just done a lot of development, and I really enjoy it. And hopefully today I can share some of that passion with you, and as we talk about containers and microservices. So let's jump right in. So the first thing we're going to talk about today is microservices. So what's really important to know is, what is a microservice? So have you ever gone to a website and it said, hey, we're down for maintenance, you can't use anything. You try to click on a button oh no, we're completely down. What you're probably experiencing when you see a website like that is what's called a monolithic application, right? So what a monolithic application is whenever something needs to be updated, needs to be changed, everything needs to be updated at the same time. So essentially the whole application is all in one place, either on one server, all the APIs, all of the the front end, the back end, the middleware, everything is all just coupled together. In the programming world, we would say that it's tightly coupled. So if you need to change one thing, you have to change everything. So when you go to a website and you see hey, we're down for maintenance, a lot of times those are monolithic websites where, hey, I want to change the color of a button. I have to take the whole website down in order to change that color of that button, in order to make that update. But that's where microservices come in. So microservices are kind of what they sound like, little mini microservices that kind of communicate with each other, but aren't really deeply coupled. They're loosely coupled. So what that means is if you've ever been to a website and maybe they're doing maintenance on one part of the website, but the rest of the website is working, there's a good chance that behind the scenes they're using microservices. So, for example, if you look here on the slide, a large system may consist of a lot of services, a checkout, a payment, different types of operations. And each of those operations are kind of broken out into smaller services that allows for, the ability to, maybe disconnect the service or update the service, and it won't affect everything else. I think about it as going back to that button analogy. If I want to change the color of a button, it will only affect that page, maybe that little, maybe the checkout button only will be affected, but the rest of the website will work fine. And microservices are really, really powerful because it allows for, a lot of diverse deployment opportunities. So, hey, I have an application out in the wild. I want to make a change. I don't have to take everything down, or I can piece by piece, put my application up, out in the cloud and slowly, build it up and get everything working. It's a really, really great way to deploy and work in applications. So let's talk about containers, because containers are kind of one of the main ways that we can use microservices today. So let me first talk about why containers. So I'm going to kind of use an illustration that has worked for me. So I don't know if any of us in this room are gamers, shout out to all the gamers. But I've been playing video games my whole life. I was lucky enough to have like a Nintendo, and then I got a Nintendo 64, and I was like really happy as a kid. And the real big thing that I loved was my Nintendo 64. And the big reason was because of the cartridges. So I had multiple siblings, and we'd always play together and play different games together. But every once in a while, I would like to play my game with my friends. So I would go to their house to play the game. And when I had a Nintendo 64, all I had to do was take the little cartridge, which was the game, and it had all the save files. It had all of the, my customizations, my unlocks, all the things that I had done like at my house with my siblings. And I could bring it without a problem over to my friend's house, and we could just plug it straight into their Nintendo 64 system, and it would work immediately with all of my saves, with everything, without a problem. Similarly, containers are the same, very similar concept. You take everything that you have in an application and you put it within a container. So that means it's dependencies, all of the application code, any kind of thing that you need to make the application run. But as far as, the environment, if it's on cloud or if it's on premise or if it's on your local machine, you don't have to worry about that. As long as containers are there, you can just move your application from place to place to place to place with ease, and everything comes with you. So it's a really powerful, powerful tool that has been used in industry. And really cool thing is containers work by isolating differences between applications. So it allows that everything outside of the container, everything that's not within the application itself, to be standardized. So it makes deployment a lot easier and just makes everything better. So you can kind of see my two pictures playing video games in containers. That connects with me. So why does that matter? So there's a big challenge in the world when you're developing, doing real world development and trying to find ways to either deploy your application or to, make your application. On the front end side, you have all type of options. You could use all kind of different setups. You could have, Ruby on Rails, and then you could have Python, and then you could have, Java, and all these different things within an application, right? So that's one part, right? And then the other side is you could host your application anywhere. You could put it on production servers, you could put it in a data center, you could put it, locally on your computer. And there's all these different kind of variations and flavors of how you can do deployments and operations. And from personal experience, it can get very, very difficult when trying to figure out how to, really get an application out there in the wild, get it out there live with all these different things. But containers kind of solve this problem. Containers allow you, as I described, to have everything that you want for your application in one place and in that container. And you don't have to worry about what environment it's going into. As long as the environment has the ability to run containers, you're good to go. So that means if I'm coding with a team of people on our local machines and we're, making updates and doing all these things, and then, we're like, okay, we're ready to deploy it, to IBM Cloud, right? Instead of having to go, okay, what version of IBM Cloud or what's this and that? Like IBM Cloud has containers, so all you have to do is go, hey, let's go ahead and containerize it with Docker, which we'll talk about here in a minute, and we can send it straight up to IBM Cloud, and we're sure that it will work just like it did on our local machine. It's really powerful, and it helps to really just make deployment and just in different ways a lot easier and simpler to do. So, okay, let's talk about how we got here. So, I think it's important to have like kind of a little bit like, containers are really cool, but like, where do we start? So, back in the beginning, I guess you could say there's the bare metal server. So that's a server that just has everything. You would have to set up, the hardware, how much RAM, how much, memory. Then you have to set up, the operating system on the server, and then you have to set up all the dependencies and all these different things just to get just an application running, right? So if I had an application where I sold dog sweaters, I would have to make sure that I did all of those steps of setting up my server just to get to the point where I'm ready to deploy my dog sweater application, right? There's a lot of work that you'd have to do. As time went on, developers and those in the industry realized, hey, like we can kind of, synergize and make things a little bit easier. Instead of having to start from scratch every time you make a new server, let's use virtual machines. So what virtual machines did was virtualize the OS deployment. So now you didn't have to worry about, what was the hardware, what the server was, and so on and so forth. All you had to worry about was the operating system and all of the things that you would need with operating system, if that was the Mac OS, if that was Linux, or if that was Windows, right? And then from there, once you, configured your operating system, you would then be able to start working on your application. But the thing is, maybe you just want to deploy your dog sweater application and you still have to worry about operating systems when to you, you're just like, I just want this application to work. And you'd have to configure that environment and do that. And that's where containers come in, right? This is where we are now, where now you don't have to worry about the operating system, right? All you have to worry about is your application and your application dependencies. So now the OS is taken care of, the hardware is taken care of, and all of that is done for you. And a container is sitting there just waiting for you to drop your code in. And all you need to worry about is your application code, your dependencies, and anything that's associated to your application. The next level is functions, and that's, that's continuing to grow, like lambdas and stuff like that. It just allows you to get, particular functionalities. But today we're going to be talking about containers and how they are used. So let's talk about virtual machines versus containers, because I think it's, I'll say personally, when I first started using containers and getting used to it, I was like, well, I've used, VirtualBox before. Isn't this similar to that? It's similar, but it's a little bit different. So kind of as I described before, a virtual machine is all about its operating system. That's where you start. So I'm going to show you this quick diagram to kind of show you how virtual machines work. So first you have your hardware, which we talked about, a server. So that's, taken care of. But on top of that hardware is your hypervisor. And your hypervisor is what manages and takes care of all of your virtual machines, resources and different things like that. And the hypervisor actually is what kind of creates the different virtual machines. Now, within the virtual machine, you'll see here at the bottom level, you have your operating system. And this is what you have to manage, your operating system, Windows, Linux, so on and so forth, and all of the processes that make that operating system work. On top of that, you have your libraries and your dependencies and all your bins and things like that are now connected to your operating system. And then on top of that, you have your application. So in using virtual machines, you have to manage all of that within that gray box, the operating system, the libraries, and all the bins, and the app. Now, when you switch over to a container, it's really now just focused on kind of more app specific. So looking at the same diagram, so you have your hardware, right? You always need your hardware. There may be a virtual machine in there, but that's kind of just depends. But you have your OS, your base OS, and your kernel, right? So that's all taken care of. As a developer, you're not really worried too much about what's running that per se. But the OS and kernel, that kind of manages how the containers are populated, memory, and how things are distributed. And within the container, this gray area, we have our OS specific files. So maybe there's some files that you need that are operating system specific. You have your libraries and you have your app. So from a development standpoint, you can really focus on the application code, and its dependencies. And as I described before, it just allows you to drop it, between different container systems. But the big difference being VMs, each virtual machine has its own operating system. And in containers, each of them have their own kernel, but they're all, different containers with applications in them. And they can be same, they can be different, and so on and so forth. So this is a little bit of illustration. So let's talk about Docker. So Docker is one of the main platforms used today for containerization. The more I dig into Docker, the more I really like it, especially coming from, I guess you could say, a traditional development and deployment background. But Docker is an open platform for building applications. So what it allows is for you to do what I described, build your app, for example, a Node.js application. And make your application. Maybe you have some APIs on the Node server. You have different things that you want to do, and then you containerize it, right? You do some functions, which I'll kind of talk about in a little bit, and you're able to build what is called a Docker, like a Docker image, and then you're able to put it anywhere, ship it, move it to any location that has containers, and you can run it, any app anywhere. And as you can see here, just from this diagram, it just shows like all the different things that you could possibly do within a container. It's way beyond that. And then it shows, it's Ubuntu, Node.js, MongoDB, so on and so forth. But even beyond that, it shows that you can kind of deploy it anywhere if it's on your local machine, on the server, in on-premise, like, in a building, or for example, IBM Cloud. So Docker is an incredibly strong tool, and it's one of the main tools used in the market today for containerization. So briefly, I just want to talk about DevOps and how containers kind of affect that. So there's this idea of development and operations. So if you're a developer, you normally create the code, you make configurations, you kind of set up OSs and libraries. And if you're on the operations side, your job is to once the application is deployed, I'm paying attention to what is the logging, how is remote access, monitoring, like paying attention to those things. And the cool thing about Docker and containerization kind of separates the two. So you have your development flow, you make the app, you put it in the container, and then you have your operations, your deployment, and being able to, pay attention to how things work out in the wild. So it kind of separates them, but it also brings them together in one place. So they're not two different, I guess you could say flows. They kind of come together, but they're kind of separate in their own way. So, dev focuses on application environment, and the operations focuses on the deployment environment. All right, so let's just talk about Docker for a second here. So as I described, this whole concept of containers. So how does a Docker work? So the Docker engine, which is what's underlying behind all of this, it manages the containers on a host. So if you look here in this diagram, you kind of see your Docker host, and your Docker host is kind of the thing that's behind the scenes running things. Then you have your Docker engine, your base OS kernel, and your containers, right? So within there, as well as your images, and we'll kind of talk a little bit more about that. So the first thing to mention is this Docker engine. I'm going to go back here. So the Docker engine is kind of what manages everything that happens in the Docker world, right? It manages building the actual containers, the images for the containers, and manage running the containers and making sure things work. And it's what communicates all of the information that's needed to the different elements within Docker to work. So the next thing is the images. So what are images? Images are basically the actual code or the application that's used to run different application code. So for example, you'll see here Ubuntu and Liberty, Java Liberty, right? So an image of Ubuntu is literally the code that is associated to Ubuntu to allow an application to use Ubuntu-based code or Liberty-based code. So when you're building your application, you may have multiple images within your container that kind of help you to manage code and do different things. So one cool thing about the Docker engine and the Docker, platform in general, is that it gives you access to just a host of images that maybe you don't have on your local machine. So for example, I'm building an application and it is dependent on some Ubuntu tools. Well, I don't have that on my machine or in my particular environment at the moment. Docker, if it notices that there's a dependency on Ubuntu, it'll go and it'll grab the Ubuntu image from the Docker registry and bring it into your application so your application can run without a problem. So you don't have to worry about, okay, I need to bring this over, I need to bring this over from here and here. It's all in one place, and the Docker engine can manage that for you. So within the Docker engine, there's a few different things that it can do, and I kind of mentioned them a little bit earlier. There's Docker run and Docker build, and we'll get a chance to look at these a little bit further, but these kind of are what, either create images or run images and allow us to use our Docker. And then kind of finally, within this whole Docker host, once you create your application and you have it hosted somewhere, your application needs to be able to, communicate with the outside world, right? So, in most circumstances, when you have an application on some type of environment, it knows of itself, but it doesn't necessarily know the outside world. Dockers allow you to expose ports and expose your application to the outside world, outside of the container. So maybe you have a Node.js application that has some APIs, and you want it to be able to be used by, maybe other containers or other applications that are not in your environment. You can expose that API through the Docker system using the expose. So you see there, you have different ports, and it will expose it on the host port. So just really briefly, basically on a a deeper level, Docker is kind of a layered file system, or I guess a layered system. So you can think about it as you have your file system, and then you have, on the bottom, then you have on top of that, for example, Ubuntu, and then on top of that you have Tomcat, and then on top of that you have your app. And I like Marek kind of shared with me this illustration, but it's kind of like transparencies. I'm just old enough to be around where transparencies were used. Basically, it was like a projector, and it was like a clear piece of plastic that they put on a projector, and they would write on top of one of them, and then they'd write oh, you're doing this, and then they could put another transparent on top of that, and they would write on that, but it wouldn't affect the transparency below it. Anyway, you should look it up. It's very interesting technology, but essentially it's this idea of layers, and everything is layered on top of each other. And it kind of builds up those dependencies. All right, so let's get hands-on. I want to show you guys a little bit of what basically Docker can do. So one big thing, just to note, we definitely want you guys to be involved and definitely participate with us today. But if you're not able to, for whatever reason, sure, just sit back and watch us as we work and do some of the things that we're doing. But if you would like to participate with us and kind of follow along, one thing you're going to need to do is download the Docker, the free Docker desktop. It's really great. It's really awesome. I use it a lot. And once you download Docker desktop on your machine, thank you for putting the link there. You can check out the link for the lab. And it has everything there, but it'll allow you to participate and to work on Docker. So you'll see there in the chat here the Docker, the link to the lab. I'm going to go ahead and open this so you can kind of see what we'll be working with today. Oops. There we go. So, oops, I'm trying to move this over to my other screen. Here we go. So as you'll see here, we're going to be doing a few different things. So first, before we kind of jump into the lab, let me show you a little bit about how Docker can work. So I'm going to open up a terminal here. So I have a terminal, and I already have Docker on my system. So I'm just going to type Docker, and you'll see that, it's doing some processing, but it's going to just tell me all of the things that Docker could do, which is a lot of things, right? So one thing that Docker allows you to do is kind of what I mentioned before is that, when you're, say you want to work on a particular, application to do something, Docker kind of grabs what you need and grabs your images and, things from a registry somewhere else if you need. And it allows you to just run it on your local machine. So it'll download it and then let you run it immediately. So for example,
Oh, I think we might have lost Bradston for just a moment. Don't worry, we can kind of follow up. So just let me share the screen, and when Bradston is back, we can kind of follow up with that. But really, what you want to have in the beginning is open the labs. The labs, the link I have over here. Let me just drop it over here. So first of all, you need to go to these labs, and Bradston is back. So I'm just trying to fill in for you.
Yeah, go ahead. I'll jump in whenever.
Yeah. So just go to these labs and then sign up to IBM Cloud, and so this is the second link. So this is to sign up, and the third link is the instructions that you can use. And let me just open the instructions so you'll see. And the third one is the Docker instructions, that the link I just shared with you. And so I'm just trying to share everything to the chat window. And if you press here, it should open for you a new tab. And in this, I'm trying to open in the new tab, and if you have instructions there. So Bradston, back to you. I'm stopping sharing my screen.
Thank you.
Still stopping.
Yeah, my internet is not cooperating today.
No worries. We my kids are on internet, not playing games, but having Zoom sessions. So supposedly they will go back to school in 1 month. So I am looking forward to it.
Yeah, I feel the same here. We have like everything running at the same time. When my wife is home, it's like, oh, this is running and that's running, and just internet just decides to do what it wants to do. So, so sorry about that, everybody. So yeah, thank you, Marek, for sharing everybody with that information. Please go through and sign up for IBM Cloud, and because the next step after this, you're going to definitely need that if you'd like to participate, and also to follow along with the Docker lesson that we're going to do. So I just want to show you kind of really quickly what you can do on your machine. So, for example, we can use the Ubuntu, image to just run some commands, right? So I don't have, my machine is not an Ubuntu machine per se, but I can just go Docker. Sorry if I can spell here, Ubuntu, and then I can say do a command. So in this case, I want to do echo. And I'm going to say, I want to say hello to somebody in the chat. Jason, I'm going to say hello to you. Hello, Jason. Right? And, oops, sorry about that. It looks like my, make sure that I have Docker here. Sorry about that, guys. Did I spell Ubuntu wrong? Ubuntu.
Probably run Ubuntu run.
Oh, I'm sorry. Thank you.
Docker run Ubuntu. Yeah.
Just thank you.
No worries. Jason is ready there.
Simple thing. I'm like, what's going on, Docker? You betrayed me. We'll do echo hello, Jason again. Sorry about that. So
Jason is going to be called a couple times over here, I think.
Yeah, so you'll see here when I do the Docker run command, you need a command which is run or build or different things like that. It actually runs the Ubuntu image, and then it says, hey, I want you to do a command, echo hello Jason. The cool thing is that if I didn't have Ubuntu on my system, it would go through and it would download it and put it on my Docker and it would run it. But since I have it, it's so fast because it's already there, and Docker is able to just execute, immediately this functionality. It's really smooth, it's really clean, and when you're doing different application development, this is a really great part of Docker. But as you can see, I have Ubuntu on my machine now, and I'm able to run some type of some type of process. Thank you, Marek, for catching that code. Man, so I was like, what is happening? So
yeah, that happened to me many times, and people were like helping me out the other day.
Like,
Hi, and shout out to Upkar.
Hey. So okay, cool. So let's dig a little bit deeper into Docker. We're gonna go and do one of our labs for today. So once again, like Marek said, please go ahead and sign up for your free IBM Cloud account, your Lite account. That'll give you access to all of the different services we're going to use today. Particularly, we're going to be using the translation service, and you're going to need an account, and you're going to need different things. So I'm going to go ahead and click this link here. This is the instructions to the lab. And you'll see here, it kind of shows a little bit of what we talked about today. What is a Docker, a little bit about an image. And what we're going to do is, our plan is to build and create an image. So we're going to use the Watson translation service, and we're going to create a containerized application, and we're going to run it on our local machine. So the first thing we're going to do is we're going to go ahead and go over to IBM Cloud. So I'm going to go ahead and click this link here on the site. And I already have a login, so I'm going to log in here. 1 second. I'm just going to pull this off the screen. And once I log in, you'll see the dashboard for IBM Cloud, which has a lot of great different tools and different things that you can use. I love exploring it and just trying out new services, doing new things. I'm a big Node.js person, so you'll find me using a lot of Node.js. I'm also a Cloud and NoSQL DB fan, so I use that quite a bit on different applications that I make. Let me refresh my page here as I still logging in here. Here we go. Sorry, guys. It looks like when my internet went out, it disconnected me from IBM Cloud. Here we go. All right. So when you come to IBM Cloud, you'll see the dashboard as described, and you'll see, if you would click this little dashboard button here in the top left, you'll come to this dashboard page. But if you click the hamburger menu up here, I'm sorry, that's what I was meaning to click. You'll see all the different things that IBM Cloud has to offer. There's a lot of great tools, a lot of great things, and I use it pretty often. So while we're on this dashboard page here, we're going to go ahead and we're going to click the Create Resource button. All right, so you're going to click that. What clicking Create Resource does is it opens up the IBM Cloud catalog, like all the products that you can use. If you were to just scroll down here, you'd see, just some different things that IBM Cloud is recommending for you. But also, there's so many different things. So, like if I click Services here on the left side, you'll just see there's just a host of different opportunities from blockchain to code engine, container registry, which is used for registering your images, so you can deploy them into like Kubernetes and things like that. So, but we're going to today use a Watson translator. So I'm going to search up here Watson, press enter, and you'll see all the different Watson tools that pop up here. Watson Assistant, Watson Discovery, Watson Studio lets you embed AI and machine learning into things. Definitely check that out. I've been diving deeper into machine learning recently. But we're going to do the language translator here. So what we're going to do here is click the language translator, and we'll see that the language translator is loading up and showing you different options. So the first thing, when you come to this page, you get to choose a location for where the server that you're going to be using the language translator. I'm in Baton Rouge, Louisiana, so Dallas is probably the closest one to me. Sometimes I do Washington, D.C., from time to time. But if you're in a different country, a different area, choose a region that's closest to you. I'm just going to use Dallas, U.S. South today. And then you'll see the different plans. So cool thing is we get an opportunity to use the Lite plan, which allows us to do 1 million characters translation per month, absolutely free. So this is, more than enough for what we're going to do today. But this is great for, if you're trying to develop a new tool and you're really trying to like get used to the service, you can really try it out. And then when you're ready and you're ready to, to move on and like maybe deploy and get more usage out of your application, you can switch to different, different plans. Standard, 2 cents per 1,000 characters. It's pretty awesome. So once we have everything set, create, we can scroll down here. And I'm going to name my service. So you can see in the service name, I'm going to call it webinar translate. Okay, I think I spelled that right. And so that'll be the name of the service on our cloud dashboard. You can put in tags, so you can put in like cloud, you can put in containers, and different things that'll help us as we're tagging our application. So I'll just leave those for now. And I think we're good for now. And as we can see up here in the top right, we got language translator for free, location Dallas is plan light, service name is webinar translate, and our resource group is default. So I'm going to go ahead and create it. So as this is happening, IBM Cloud is spinning up our service and creating a instance for us to use for our application. So just popping back over to the lab instructions, just so you can follow along. That was step one. So we're going to now start on step two. So the next step here is that we want to use our translator service in our application. But in order to do that, we need to have our credentials. And basically what the credentials allow is for us to integrate integrate into the translator service, and for the service to know it's us who's using it, right? Oh, it's Bradston that's using the service, not somebody else. So what we're going to do is on this left side, we're going to click service credentials. And you'll see it has an auto-generated service credential, but I'm going to make a new one because we're in the class today, and you guys will be able to see my credentials. So I'm going to call this webinar creds. Zoom in a bit. Yes, Tom, I will absolutely zoom in. Thank you. Let's do this. I hope that's better. Let me know if that's better. I can zoom in some more. Thanks for that suggestion, Tom. So let me back out here just so you can see. So if you're here on the credentials page that I clicked on the left side, you'll see on the right side. Yeah, no problem, Tom. You are welcome. I'm going to click new credentials. Here, you can name our credentials. So I'm just going to call it webinar creds. Oops, missed my D. And then I'm going to say add. Okay. Once I add, it's going to generate a new credentials for us. And you'll see down here at the bottom of the list, webinar creds. I'm going to go ahead and open it. And you'll see that it generated what a JSON kind of format file with our credentials. Essentially, what we're going to be using today is going to be our API key, which is going to be used to connect with the service. And we're going to need this URL. And we'll see in a minute for the actual application we're going to be using, we're going to need that URL to connect. So that is kind of set up. So we'll leave this page open because we're going to need this in a minute. But we're now going to work on the application we're going to use for the translation. So the cool thing is we got some code to kind of help us already get started from scratch. We're going to go ahead and use some code provided for us in this in this lesson. So you can there's two different ways you can get this code. One is you can clone it, and I already have it cloned on my system, so I'm going to have that. But the so if you have Git on your machine here, so you just do Git clone, so on and so forth, and you would then CD or change directory into the file so we can use it. And then once you have cloned it onto your machine, you can build that using Docker. So I'm going to show you kind of the alternative method as well. It's kind of like how cool Docker is, in that Docker can actually build straight from a repository that's already set up. So in this case, it's a Node repository, and I'm going to show you this in one full go. So I'm going to open up my terminal here, and I think I'm zoomed in a little. Oops, there we go. There we go. Make sure I'm zoomed in good. And I'm going to go ahead and I'm going to copy this command, but I'm going to make some changes to it. So let me explain what's happening here. So in this command, we're telling Docker to build an image of this particular application. So you see here, Docker build. The next step is this -t, and this -t is tagging our application in our Docker system. So you need to give it a username and then a name / the name of that container. So I'll mention here, if you have a Docker Hub page, and you should sign up for Docker Hub because that's where you get it to store your your Docker images that you create kind of remotely, you would use your username on Docker Hub. If you don't, you could use any username. In this case, I'm not going to connect to my Docker Hub account. I'm just going to use my nickname that my uncle gave me when I was a kid as my username, and then the name of the container I want. So in this case, we're going to delete this angle bracket section, and I'm going to put in King Brad. Yes, my uncle when I was a kid. Oops. Just a side note, it needs to be all lowercase. If you do uppercase, it'll have issues. So my uncle used to call me King Brad as a kid. So, I feel that I should continue to carry on that legacy. But, you'll see we'll have our username, then this backslash, and then the name of our container that we want to name it. So in this case, we'll call it node container. After that, in this case, because we're going to be building directly from a repository, we just put in the location of that repository. So in this case, it's the GitHub, IBM Docker Node.js language service. Let me expand this a little bit. Thank you, Ufkar. It is a great nickname, and I try to live up to it every day. So I'm gonna go ahead and press enter, and it's gonna run. And then we'll talk about exactly what happened behind the scenes when it did this Docker build here in a moment. So you'll see what's happening is at the beginning, it's going ahead and grabbing the source, which is our GitHub, and then it's going through the commands that would create this Docker. So what are those commands? So I'm going to open up here the actual code for the, let's see if I can zoom in here. Well, I guess I can't open up here, but this is the actual code that I just downloaded from the GitHub. I'm going to open up the Docker file here. So the Docker file, and we'll talk about this a little bit more. Oops, there we go. Sorry, let me zoom in here. Zoom. There we go.
I was trying to ask you for zooming in because it's minuscule. I'm like trying to be very close to the screen, and I'm like looking like this. Like, now I see it.
Better? Okay.
Good.
Okay, cool. If you need me to zoom in a little bit more, let me know. Okay. So we're going to look at here the Docker file. So what is the Docker file? The Docker file is actually the command that Docker uses to create our image. And our image, once again, is our application that would be stored in a container. And it's kind of a directive file, so it kind of goes step by step, and it tells what exactly is going to be done. So let's start with the beginning. So from node 10. So from node 10 basically says, hey, there's an image called node, and I want the tag 10. So node is the name of the image, and 10 is the tag of that image. And I want to use that as kind of, something that a dependency for my application. Now, if I had this on my local machine, then great, we can just go use it. If not, when I run this command, Docker will go ahead and grab it from the Docker registry, which I talked about, which just holds all the images, and put it in our machine, right? So it'll pull that into our machine. The next is, I'm going to set some environmental variables, no container version 1.000. The next thing is within that Docker, I guess you could say, image within its file system, we're going to go ahead and create a working directory. Basically, the directory is where all of our application files will exist and where we will run all of our code out of. So you'll see here, so you run that build locally, not on VM or IBM Cloud. That's a good question. So because of how Docker works, it allows you to build it locally, in the Docker container, but almost exactly the same. It's almost exactly the same when you deploy it to the cloud, right? You can actually take this image, and later, Marek will talk a little bit about it, is you can actually put it up in, for example, with IBM Cloud, you put it in the container registry, and then Kubernetes will then deploy that application out into the cloud. So the build locally is kind of how you run it locally, but it's exactly the same when you're running it out in the cloud. And that's the real cool thing about, containers. It allows you to basically do the same kind of code deployment and development in all environments. So let me know if you have any more questions about that. So yeah, in this case, we're going to run it locally just to kind of show how it works. So once we've created this working directory, which we're going to call data translator-app, we're then going to copy in our package.json. And if you're familiar with Node, that's where all of our like Node modules and our dependencies for our Node.js application dependencies are written down. I'll show you what that looks like just so you have an idea. So the package.json, sorry, I got a lot of files in here from other work. Closing that. Package.json. Here we go. And then, so yeah, so the package.json has, you know, the dependencies that we want to use, which when we get a chance, we'll look at the server.js file, which is what'll make a little bit more sense on why those dependencies matter. Once we've got the dependencies, we're going to go ahead and install them into our Docker image. So that's the npm install command. We're going to run that. Then this copy ... here actually copies over all of our files that we have here in our folder here into the working directory here. And once we do that, we expose 8080. I mentioned this before, that in a container, in order for the outside world to interact with it, it needs to expose itself, I guess you could say. And then this command here is just saying this is the command that you would need to run our application, which is node server.js. So what environment do you have set up locally? Do you run it straight on Mac or on Ubuntu or similar VM locally? So the cool thing is that that's kind of where the Docker hub is kind of the main meat piece. So you install what is called Docker Hub, and I'll just show you what it looks like here. Once it opens, where is it opening? Docker Desktop, sorry. Docker Desktop on your machine. And Docker Desktop is actually what manages your images. It allows you to make your manage your images. It allows you to build images. It allows you to run images. It allows you to do all of these things. So you'll see here, earlier I used the Ubuntu image to run Hello Tom, I believe. I can't remember who I said hello to. But it's here in my Docker desktop application. So if you download the Docker Desktop, which is, we can share that in the chat here, but you are able to then have access to all the tools to build your images and do everything on your local environment. Okay. So that's kind of what's running behind the scenes. So once we have, okay, Docker file, that's what creates the image itself. Okay. So just for really quickly, just to show you kind of what the server does. So what the server does itself, the Node.js server, is first it needs to get expressed. That's why we had some in our package.json express. It uses express for its like for all your, I guess you could say, your API and HTTP request type things. And then our language translator, which is our IBM Watson language translator, which we need. And here's the port. Host is not necessarily used right now. And here's our version of language translator. And here's our URL. You'll see here, process that environment. It can get that. If it doesn't get it from us, it'll use this default. And then you'll see it has the language translator, which we need our API key, which I was discussing earlier. And then, here we go. And then you'll see that this is the actual code that does the translation and that outputs it. So check this out. I definitely encourage you to check out the link that was just posted. It allow you to kind of look at this a little bit deeper in your free time. So let's go back to what we're working on. So we've created the image. It's for our translator service, and it is now on our machine. So let's go back to our steps here. So we built the Docker image. We used the build.d command to get it from a repository. Here on the same page, it explains a little bit about what I talked about in the Docker file. So our next step is to actually run the Docker image. So what's really important to note about this is that there are certain parameters in order for this to run correctly. If you look here, and I'll see if I can zoom in a little bit. Oops. There we go. If you look here, we have Docker run -p 8080, so on and so forth. And I'll explain this a little bit, but these are all the different parameters we need to run our application correctly. So we're going to do this command, and I'll show you how it works and how we can use it ourselves. So I'm going to go ahead and paste in that code, and we're going to make some changes here. So going down through how this command works, the docker run command that actually runs our image that we just built. So docker run -p. So -p is where it's going to actually choose the ports that will be exposed outside the container. So within the container, 8080 exposes the container to other containers and in the environment, but we need to expose it further outside of the container environment. And if you have any questions about it, we can talk about that a little deeper. And now here are some parameters. So the first thing that we need to run this is our API key. So let's go back to our Watson service, webinar creds, and we're just going to go ahead and copy our API key. We're going to come in here, and I'm going to go ahead and delete this angle bracket and paste in our API key. All right. Then from there, we have our environmental variable, that -e is our API URL. So let's go ahead and grab our URL, which I showed you guys a little bit earlier. Copy that. I'm going to go back, and we're going to paste it here. There you go. Now, and this is important, the next step is this is the actual Docker that we're going to be running against. So we just need to make sure that we use the same, Docker that we called earlier, not yesterday. And in this case, mine was called King Brad because, that's an important, oops, sorry, I didn't move over my cursor. It needs to be King Brad /node container. In your case, it's just whatever you called it. So we're going to call mine King Brad. So I'm going to run this. All right. Okay. Oh, okay, cool. It looks like Marek answered some questions. Hopefully.
Yeah, I think I won't forget King Brad anymore. This is going to stick.
I need to get a little get some image recognition so that the crown is always on my head when I'm talking. That'd be awesome. But I'm going to go ahead and press enter here. Now, oh, that was exciting. it spit out some like a random thing. Well, behind the scenes, the Docker has just begun running. So I'm going to show you two ways that you can check to know that your Docker is running. So one way to check is to do a command called docker ps. And what that does is it shows all of the Dockers that are currently running on in your environment. So docker space ps. And you'll see here my image container ID. Oh, actually, that's what that was, the image container ID, right? It just spit out the ID for us earlier. The name of our image, the command that started it, and then when it was created. So this was very soon, and it's showing also the port that is currently being exposed to. Also gave it a cool name, auto-generated a name. So that's one way to see if it's running. The other way is is to actually open Docker Desktop, and you can see it in there. I closed it earlier, I guess. And you'll see on mine, you'll see at the top, it's red, it's green, it's called Festive Gauss, and you'll see that my container is running, okay? Let me know if you have any questions about that. So once we have it running, we can finally test it. So if you can test it in different ways, but in our terminal, we can actually test it using the command curl, and we're going to use this. So I'm going to copy this. So one thing I forgot to note is that in the actual server.js, the default language that it's going to translate against is Spanish. In this, you'll see here, translate parameters is en-es, which is English to Espanol. Okay. So I'm going to copy this code here, and I'm going to run it in my command line. So this is, once again, the curl command, which is going to reach out to my local host, which is at port 8080, which we exposed earlier here, this line, 8080. And we're going to run this query command. And I'm going to press enter. Oops. Let's see what went wrong. Sorry. Did I do something wrong here? Something went wrong. Let me try again. Did I do something wrong here? Does anybody see any errors that I wrote in this code?
Yes, there is. You didn't copy the language translator URL. There is an API URL in the brackets. You have to copy there this URL as well. So.
I talked about it, but I didn't actually paste it. Oh no, I pasted it in the wrong place. Thank you for catching that.
I think Khalid was mentioning. I was like,
thank you.
What the heck he's talking about? And now I understand.
And I have this habit where when I'm on command line, I think that it works like the normal, how things work on a computer. So I'll click in the area and then I'll press Control V. But I got to remember that I need to actually move my cursor. Thank you.
So you have to put it in both places. So LT key and LT URL.
Yes.
Yeah.
I just.
Khalid, thank you so much for finding this out. It's really helpful.
As you can see, I'm a copy paste fiend.
Yeah, Jason is mentioning that that you haven't pre-recorded that. So thank you.
You get to see it again. Let me get the URL. Sorry about that, guys. I didn't realize that I pasted in the wrong place. This is like programming life. You don't realize you make mistakes. You're like, what's going on? And somebody looks at your code and they're like, you know that you're not even running it in the terminal, right? Okay, so everything looked good. Let me go ahead and stop.
Mark is asking about the link to the page where you got, I think, API key. I think it's if you can open once more the page with the webinar translate is the service Watson translator service, and you go to the service credentials and you create the service, and then you can produce this JSON with the credentials to the service. It's all based on the Lite account for IBM Cloud, so should be easy. And Chris is asking if there's going to be a recording. Yes, if you come back just right after this webinar, on the same link we'll have the recording. So.
Yeah, and just for
Go ahead.
Go ahead, Marek. Sorry.
Yeah, I just wanted. So I asked. So I think we can answer Mark, and Tom is asking question if we generate the key for each service separately. So it depends. You might have like a one service for everything, and the reason is the payment for the service. So if you are creating a Lite account, you have a free of charge service. But when you are working in the environment, company environment, maybe you want to have like a company standard for that. So probably you would have just you can have you would have one service, and this one service you would generate the key for every application. So if you sunset the application, you probably would just remove this API key. And it's good to have an API key just for reasons like Bradston just generated that for this webinar. So you would have one application, and if it's something was messed up with application, you can just remove particular API key instead of removing the entire provision service that has, for example, a specific price point for using. I hope it helps.
And just for anybody who's interested in trying to figure out where your API keys are located, if you already created the service and say you couldn't find it, if you click up here in the hamburger menu and you go to your resource list, you can scroll down to services and it'll show your service you created, and then you click on that service, and when you get back into the service, it's loading up here, you will then navigate to the credentials area here. So on the left side, service credentials, and then you'll see your credentials here. So you see my webinar credentials, and you can create new ones. If you haven't created the service yet, I recommend you go to the links that have been shared, and you can go through the steps to create a service the first time, and it'll automatically bring you to this page. But once again, the credentials are just within the resource itself in the service credentials area. Okay. So I think this time it looks like I put everything in correctly. Let's try this again. I'm going to go ahead and say Docker PS, make sure it's running. It is running. And we're going to try to run this again. And yes, there we go. So you'll see here, I was translating the text, how are you? From English to Spanish. Marek, do you speak Spanish? Can you say?
Oh no, I speak just French, so I'm always trying to add this small question mark and adding the French translation. And
so
yeah, you can go. Yeah,
I speak Japanese. I speak Japanese, so let's do Japanese. So I'm going to switch this here. You'll see as Marek was mentioning, you can add the question mark at the end of the request. And then you can change and add the and lang equals. And I'm going to put JA, which is for Japanese. Oops. And it pops out in Japanese. And that says, Anata wa do desu ka? Yes, I still remember.
Watashi wa ii desu. Watashi wa Marek desu.
Watashi wa Henry desu. Dozo yoroshiku.
Dozo yoroshiku onegai shimasu. This is a little bit of the Japanese over here. I forgot how to read all the kanjis and hiragana and katakana, but it's awesome that you can read this through.
Yeah, I went to Japan 2 years ago. Actually, I think I saw one of my friends who I met in Japan was in here. I'm not going to call his name, but we went to Japan together, so that was an amazing experience. That's neither here nor there. If you want to learn about my Japanese trip, please join the Discord. I'm in there now, and I can tell you all about it and share some pictures. It was an amazing experience. Definitely recommend it if you have an opportunity. So with that being said, as you can see, the translator service works. We connected everything. We created our container. We created the image. We ran the image. Then we connected our service, and we're able to use our translator service. So definitely have some fun and experiment with this, and get used to using the container. So I'm going to flip back to our presentation here, and you'll see this is what I did a little. Describes a little bit what we did. This is what we just did. So once again, don't forget to sign up for IBM Cloud. This will give you access to the whole catalog, use different services. If you don't know where to start, I tell everybody, try the translator service, use the Node.js. And I personally really love Cloud NoSQL DB, so I recommend that. So with that, I'm going to go ahead and hand over the controls to Marek. Let me close. Oh, somebody's playing.
All right, so that's now me, I think. So let's start. But it's my wrong screen. Is it the gaming screen?
I think so.
So yeah, maybe it's my gaming screen. I'm so sorry for that. Please forgive me. All right, so second part is on orchestration, and this is my hometown, Gdynia, in northern Poland. It's a port city and shipyard city. And Tom was asking about the book, so Serverless Swift, and this is also our Discord space. So if you come over to Discord space, it's just based for the book I publish. I'm so happy about that. My first book, and as you can guess from my San Francisco accent, it's not my native language, so super entertaining to write in English and have the book on serverless, which is the competitive technology for containers. Nonetheless, it's a great book. Feel free to kind of get hold of it, and the Discord space is supporting the book. So if you have any question about serverless or today's workshop on containers, feel free to join me and Bradston over there, King Brad. So So when you started with just one container on that's fun thing to have, and you can kind of run it in the cloud even, but it's going to be entertaining to see people joining you, and let's say your service is going to be popular in Japan and popular in Europe, in South America and Africa, in other places, and suddenly you will have more and more clusters. I mean, more and more containers running, and it's getting to be a headache in some moment of time. You would like to restart them, and you are going to lose some time on that. So suddenly you will have like really a large number of the containers running, and it might be difficult to kind of get hold of it. So people started to think and propose something that is called container orchestration. And this is the second part of our lab, introducing you to the container orchestration, the thing that helps you out to schedule your containers, manage the clusters, discover the services, provision new containers, to monitor them and configure what is happening. And the general overview of such a deployment is to have let me just bring the pen that I love to use. So you would have this manager that is going to take care of everything, and you would deploy your containers on the physical machines somewhere in the cloud, so provided for you in a cluster, and you would have some daemon that runs here, and you would deploy the container. So that's the basic idea. And you would use image repository, for example, a Docker Hub or some other repository that you would download the images to your nodes. And Tom had a question, and it's a very valid question. So what we have done on our laptop that King Brad was showing. So you have written a small container. The small container is running and is using some cloud with the translator service. So this small container is kind of using this small service and responds to the request. And I've even written a small Discord bot that would respond to questions. But whenever your laptop is down, then you would say, "Oh, my service doesn't work." So when you deploy or push the service to the image repository, now you can deploy this image. So this is King Brad image. You can deploy it over here, and you can then run it. And this is kind of the idea. So you would push it here, and it's going to be, and if you have the credentials, so if it's a public image, you can then use it. So there are a couple of various so there's a question from Abiodun Teresa about her Light account. So the challenge is we can resolve that. Please try to come to our Discord account. We won't be able to kind of deal with that now, but try to connect with us on the Discord. I've sent a little bit up on the chat. There is a link to that. And so yes, so Tom is asking, do you push your image to Docker Hub? Docker Hub is one of the places that you can push. They are also private and sophisticated image repositories that you can use. From Docker, you just kind of point Docker to this environment, then you would push the images there. But orchestration, there are a couple various orchestration engines. We will be talking about Kubernetes, but there are also others that you can kind of use. And if you think about very small deployments, probably you do Swarm. Small, that means that maybe 10, a dozen of the the containers. But really, everybody are starting to use Kubernetes, and it became de facto a standard. So Kubernetes became a standard. It's an open source project, so everybody likes to use it. It's extensible. You can add additional features. I will be talking about Istio, one of the features that you can use. It's orchestrator. It's not managing your machine, so it's kind of tricky if you want to install it on top of your infrastructure on-prem, and therefore you would use something that we are going to talk about, like OpenShift. And this is the kind of, I was talking about master node. So master node is going to kind of manage entire infrastructure. We are getting a cluster that you can claim, and these clusters are based on the 3 nodes. Nodes are the, as I said, kind of the virtual servers that are provided for us, and they are defined in such a way that every service is having 4 virtual CPUs. And so let me just finish drawing this. I'm using my pad here. Okay, so so we have like a couple of the servers here, and Node is going to deploy a thing that is called a pod. Whenever you have an app, so the basic deployment element is a pod for Kubernetes. And in a pod, you would install your app. So how you would install it? So you have your image repository here, let's say Docker Hub. Bradston, King Brad, uploaded or pushed his image here, and now he wants to run his application. So from the repository, you would reference your pod. In your pod, you would reference your app, and you would say download this app from here. And it would just install your app over there, and then you would say, for example, I want to have 3 replicas of this app. So the app then would be distributed by master node on 3 different nodes, and this nodes would just create the copies over here. And that's kind of how the microservice would be shown. But that's not everything. In order to client to consume now, if client comes, so your application or your curl command would like to come, it's not able to kind of get into it. So in order to kind of enter it, you have to spin a service. So service is kind of a front end part of the application, like a logistic application, and it gives the gives the direction where to kind of exposes the app to the outside world. And some of the applications might be not exposing anything, so they might say they are just for internal use. So for example, if you have some database you don't want to expose, it would be only possible to kind of address this application from inside. So this kind of inside. And Tom is asking, is OpenShift a type of the Kubernetes? And it's a very, very good question. Let me just try to answer it right away. So first, is Kubernetes a part of OpenShift? Yes, OpenShift is, or OpenShift is a flavor of Kubernetes, is a opinionated set of the projects containing the main project, I would call it, which is the Kubernetes, and as a product. And this is what the OpenShift is a product, managed product. Think about this like a CentOS and Enterprise Linux from Red Hat. So it's like opinionated and managed and maintained version of the Kubernetes. Jason is asking why Kubernetes is over other options like Swarm. I think let's finish this, and let me just ask this question, and I will ask this question. So there are 2 questions. I will start with the other question that Tom asked. So App A service is part of the master node, no, not. It's a master node is just a service that browses everything around the environment of your clusters and checks if the pods are according to the number of replicas that we designed. It checks the state and so on. App service is just a part of the deployment for your application. So application A is kind of deployed in a pod and in a service. So this is kind of like a setup it has. And Jason is asking why Kubernetes is over other options like Swarm. I think it's just the sophistication of the service. People started to use it because it's such a well-designed piece of software capable of doing a lot of things and open source. So this is it happened that a lot of people started to use it over past 3-4 years. So it became a leading project. I will leave it at that. You can check some information. Our colleagues are usually saying that really everybody who wasn't using a cluster or container orchestration services, they switched from non-using to Kubernetes, and the other projects weren't used that often. Also, Tom is asking, is OpenShift Red Hat specific? I will talk about that. It's part of the OKD implementation. So in this OKD implementation, I will talk to it in a moment. You will see how it's kind of how it's being positioned in the environment. So let me move to the next slide. So Kubernetes is allowing you to have a kind of intelligent scheduling. So you can say from the gaming environment, you have this huge event happening. So let's spin 1,000 clusters on this date because you are having to get like a Fortnite event for kids, and you need to be prepared for that. So you want to spin more clusters, and then during the regular days, maybe you don't want to have so many. So you can spin down some of them. You can have a self-healing. So first of all, you will have a probes allowing you to see that the service is ready, and then so liveness, and then you would have a health check, and you will say, oh, the container is alive and pod is alive and responding. So you will have checks, and if they are not working, you would restart the service, so it will restart. You can have horizontal and scaling, so you can have small clusters, medium-sized clusters, and large. So 1, 2 nodes are small, 3, 4 probably medium, and then you have very large installations for commercial use. And then you would have a service discovery and load balancing. So very simple ingress kind of load balancer in front. Doing a round robin installation, so you can kind of deploy it quickly and working with that. And then when you deploy the application, you can have a deployment. And if application is not starting, you would have a rollback, automatic rollback to the different version. So it wouldn't allow you to roll out the application that is not fulfilling the health check start. And you can also, if you have some tokens, like Bradston was showing. So if you have some tokens, you would kind of provide it as a secret to the cluster instead of putting them, like I'm always saying to Discord bots. You don't put the secret inside the file. You just pass it over to the environment. So nobody can kind of steal it from some file if they get the access to your GitHub repository, for example. One of the things that you would like to have is the deployment based on the Helm. So if you have your Kubernetes deployment, you can wrap it up in a Helm structure in a YAML file, and then you can bring it up to the different environment, to the different customer on different cloud that is using Kubernetes, and that's kind of like a easy way to deploy this type of the environments. Now to get back to the problems that you have. So sometimes you have some problems that are described here, and they are not answers to those challenges in a deployment, and you would like to kind of improve what you have and kind of play with all those challenges. And people came up with the idea for the service mesh specifically, so you can observe. You can have a resilient service mesh, so a lot of microservices that are interacting with each other. You can have a traffic control, so what is happening, where the traffic is going. You can have some security measures between services, how they are talking to each other, and you can have some policy, so somebody is not, exploiting all the environment. So a project called Istio came to life. It was funded by IBM, Google, and Lyft, but a lot of other partners joined in, and Istio community is growing. It's almost it's a very stable project. It's used for connecting the microservices, for securing the communication between them, to control how they are kind of behaving, and to monitor what is being done. Basically, what you would see, it's really Istio project is the smart load balancing, intelligent routing, allows you for A/B kind of tests or canary tests, so you can drive 1% or one browser or one client coming from some environment. You can direct them to the new version of the application, so you can do very small changes, and it's in a fast evolving environment, it's a good thing to use. It allows for resiliency tests. In fact, you can inject some problems and test your application, how it responds to, for example, timeouts and so on. Chris is asking a question. Let me just try to promote it as a question. Try to answer that. So in the service mesh approach, are there special precautions needed for a DB microservice? Do you treat app and data microservices differently? That's a very good question. For usually in a service mesh, microservice is a microservice. Doesn't matter if it's a database microservice or something else. However, database as a service, you want to have really address a couple other options or challenges, which is the making the data available globally, and these kind of challenges, and also the volumes or the storage behind the microservices. That's another thing that you would like to address. And I think this talk is not kind of addressing this directly, but you can find a lot of information beyond that, and my colleagues would probably invite you for the next events that would talk, for example, on how to create a MongoDB microservice and how to consume it, or something like that. So that's how I can answer now. It's another microservice, but usually databases require to look into the storage, and that's kind of a bummer, and the synchronization of the data. So finally, we have two more things over here. So you would have a reporting, that's one thing, and you would have also a policy enforcement. And let me just try to skid to the architecture of our app. So I was showing previously the pod. So this is our pod. In a pod, in every pod you would deploy, Istio is deployed as there is a small proxy that is being deployed. And this proxy is taking care of all the I/O communication. So it's creating a tunnel over here in which the communication is kind of passed from microservice to microservice, and you have like a basic deployment environment in which you would navigate the traffic. So that's the control environment, which gets the telemetry information and so on, and that's the very high level overview of the entire environment. When you install the application in Kubernetes, you would have some pods having versions of the applications, and these pods would have such a kind of architecture. You would have the product page on some HTTP server, and then you would have some microservices providing you the reviews, live reviews, and you would have some other data over here. So now, when you want to switch between those in a vanilla or default Kubernetes, it wouldn't be that easy. But when you use Istio, now you can have this particular element that was used, this proxy, that is being deployed in every pod, and now it can help you out to kind of let's say 99% of the traffic goes. You can say you can define it goes to reviews version 1, but let's say people on iOS apps or iOS browsers. So they would be directed to version 3, which is the colorful reviews. So version 3, and 1% of the traffic would start to use revision 2. So you can kind of test it in such a way.
Marek, it seems like we have a question about Istio. Is Istio also an API management system?
Let me try to see. Is Istio also an API management system? Istio is yes, it's a API management, but it's tailored to manage microservice mesh. So when you have application like this one that I'm showing over here, it consists of a couple APIs so that would be, let's say, that's API that is providing reviews. There would be a detail API. So these two APIs are distributed in various versions. So it's for this microservice mesh. It provides you some connectivity, and it can be a smart load balancer. So it would give you iOS would go to version 3 and so on. So it's a very high level view. I don't want to go much deeper into the explanation, because it's a separate subject, and I want to move to our labs now. So I hope it answers. If it's not enough, let me kind of go forward to the next step. And Jason had the comment. I will try to answer that later. Maybe I can promote it later on for the question or comment how to do it. So I promoted to the question. I will answer that. Is it promoted already? Yeah, I think it's asked the question. Is it there? No, it doesn't want me to promote it. Yeah. So let me move on. Some people were asking, what is Kubernetes? Is it OpenShift specific or so? OpenShift, as I said, is based on the open source project. Was based on the open source project, and is which is the origin community distribution of Kubernetes, OKD. And this is like a open source opinionated group of projects taken together and one major part of this project is Kubernetes itself, and there are some other elements, and for monitoring there are a couple others, but Istio is one of those. So Istio is one of the projects that is also being taken into this group, and Red Hat created this project to kind of spin the OpenShift. So OpenShift is the part of this project. I mean, it's a product out of this open source project that Red Hat is licensing and providing with you with all the elements. And so this is kind of the architecture, and I will give you kind of a view on what is the Kubernetes versus OpenShift. So OpenShift, as I said, it's is based on the open source project OKD, and Kubernetes is one part of this project. So you have Kubernetes, you have Docker, you have Istio, and the difference is that OpenShift is just opinionated, maintained product that you can buy a license, and we are going to explore it. But it's in fact, it's just a wrapper around Kubernetes that gives you a lot of easy way of working with it. So when you start with the deployment, for example, in Kubernetes, you would start your cluster. You would start with the image. You would create some image in the image repository, and then you would have a small deployment in the cloud. You will create the pipeline yourself. You have to figure it out yourself. In OpenShift, it's everything is simplified to project. You create a project and you have all of this taken care of. And then when you manage your applications, you will see, you will have a very nice, in OpenShift, you have a very nice UI that shows you dynamically what is happening, and it uses some platform to give you the monitoring for that. In Kubernetes, the UI is based on what is given, so it's very small. You use Elasticsearch, Log DNA, and Kibana to kind of view what is happening. You would use Istio, but in OpenShift, everything is given for you. Also with the security, as you know, security is the huge thing for Red Hat, and so in OpenShift, when creating the project, it's already giving you the best standards inside. With Kubernetes, you would have to really work with the role-based access control. You would use IAM services, provision them. You would have to configure them. Authentication, authorization. You have to really implement those and monitor it by yourself. Over here, everything is done. With Ansible, when you add, you have to increase or enlarge your clusters. You would do it very quickly. It's a very, very simple process. In Kubernetes, there is a way to do it, but it's spinning your new cluster and then managing it. So it's really a little bit more intensive approach. So Kubernetes is open source project. You have to really know a lot and gather all these elements. In OpenShift, you get opinionated view from Red Hat that is providing you with the maintenance. So that's the difference. And I think that gives us that's kind of the wrap for the introduction, and we can now start our lab. So this is look to our Discord. So if you have any questions to the labs, I'm going to do. You can come over here. This is our GitHub repository. I gave you the link, so let me repost the link once more over here. I will resend the invite once more, so no worries. Let me just do it again. Invite people. It says my invite link expires in 7 days. So now let's so you can join us over here in this channel, Intro to Kubernetes. So I'm saying hello, and now we are going to go with this with the labs. So I will go with the let me no discard these guys, and we will go with the labs. So first of all, the labs, we have two labs. So first lab is the image to cluster. So image to cluster is deploying the existing image to cluster. So if we open the link in the new tab over here, so this is the link how to do it step by step. But first of all, we need to get hands on our cluster. So we have to get to the cluster. So you have to use this link. Hopefully it's going to work. If you have any problem with getting the link, getting the cluster, you can go to the Stretch lab, and it's based on our Stretch environment where you can use the environment that is going to be available after this workshop. So so when you come over here, you will get a look at our clusters. So we have provided for you 20 clusters of OpenShift. Let me just bring them over here. So I have 20 clusters that are available. Some people started to use them already. I'm not sure if it's going to refresh, or I would have to re-log in again. So let me just try once more. So these are the clusters that we have, and so there are still clusters available. You guys can access it. And how to access it? So first of all, you have to click on this link. I think that's the no, it's not this link. So if I click over here, open a new tab, it should open for you a link. And in this link, you have to put the OS lab as the key. So you want to put the key over here, and then you have to put your email address. So so I don't know. You can put serverless Swift or serverless. I think I have serverless Swift at roboticsind.com. So this is to my book, and then you would wait, and your cluster would be assigned to you, and you can. There are some hints on how to do it. So so if you want to really see step-by-step process, it can be. We have provided for you, as I said, 3 nodes, and each node has 4 CPUs and 16 gigabytes of RAM. And you should see such a screen when you sign up. So I got this link. I got OpenShift Intro 03. This is the cluster I got. This was empty, and these clusters are available for us for 24 hours, so we can test infrastructure. It's dedicated clusters. So so if I connect now, you see how many people are already signing up to the clusters. So we have a couple of people already joining us. And you will see them. So my cluster is number 3, and with cluster number 3 now I can go through the lab instructions. So lab instructions are here. So if I open this link, you will get the very short instructions on how to kind of work with your cluster. Okay. So first of all, you have to open the console. And so let me try to do it. So this is my cluster. So if I go over here, one of the things you have to do in order to see the cluster, you have to be in this account. As you see, I have a couple organizations. Usually, you need to reload your dashboard in order to see it. But you would see this number over here. When you see it, that means that's good. and you would open a web console. So let me ask the question and get the poll over here. And Tom is asking, is the environment going to be available after the session? So we have the environment for one day. However, there's a stretch goal, and you can use our Open Lab environment that you can hopefully can use after this session, in addition to what we have. So so if you come to our descriptions over here, this environment is able to provide you with the environment to test very simply the application, but also you can kind of do some other stuff. So just if you go here, you will be able to kind of access the quick labs through skill networks, and you have to provide your login. So so if I provide my login, I will be able to kind of run the test after the lab. So it's environment with the entire environment provided for you, and you can kind of go through the very basic tests that are similar to what we are doing now, but today we are doing like on dedicated cluster. So after having my cluster assigned to me, you would need to open this. You would go to this link to this account. You have to change it from your private one to this number 1840. Just increase the size. So 1840 867 advo.work, and then click Open OpenShift Web Console, and you will see something like this. This is our overview. You have view as an administrator. This is the basic look. So as an this is not available on the skill network labs. This environment is provided for you. As I said, you are an administrator over here. You will see much more. And in different environment, the SNL labs, you would be just a developer. So as a developer, you have a couple projects over here, and so if you go, for example, to default project, you are now able to start a new project, and we will start with the container as an image. So it's described in details. As I said, if you go to lab number 1, and if you open the new it on the new tab. So let me just copy this link as well over here. So this is the lab we are going to do now. So that's the first lab that I'm going to do, and this lab, did I open it? Yeah, so we are going to use existing image. As I said previously, King Brad created an image, push it to the Docker registry, and now it sits there. And this is more or less what we are going to do here. So we are going to use the container image coming from, let's say, from the Docker hub. So I'm going to click on this. And now we are going to use my other colleague lab, which is Niklas Heldorf. He's author of a small microservice for the book registry. So I'm going to use his registry image, and it's going to look for it. So it's validated. And so we are going to use this image over here, and this image is now starting. And so we have some problems. You can see if there are any challenges with the image. So you can kind of go through entire process of deploying of this environment. You can see a lot of things that are happening, so you can really see the value of the environment. So as soon as the image is ready, you can You can see the how it's being deployed, what are the routes, and so on. So you have some, you can add some health checks as well. And when it's ready, it's going to open like this. If you click on the link, so I just click on the route over here, and I have the link. And now what you need to add, you have to go to the application itself. So so I think it's Open API and UI. Is it like this? Let's see. Yeah, it's the link. I'm following just the recipe over here, so you will have all the steps described. I open this image. I use this link to open it up, and I added the Open API UI. And now you can test it. So I will try to get the information from it, and you can try it out. And if I look for the Niklas Heldorf, it will open up the application, and you can kind of see that that was the part of the running of the application. Very quick run, and that's the kind of the first dipping your toes into the water and trying out how to deploy an image. You can also use your own image. There's some way to do it, but we will go to the next lab now. Let me see if there are any questions. I'm trying to kind of go fast through it, and you can watch the recording because we passed our time over here. So so I'm going to do the lab number 2 quickly. That one is going to take us a little bit more time because it's a little bit more intense on various processes. So lab number 7. So I will open it in the new tab over here. In the same time, I'm going to go through lab number 7 as well here. And so I'm going to deploy the code from the GitHub repo. So so what I need to do in this case, when we are in our lab over here, so we need to be in our environment, and instead I am going to click on this on this link here. So I'm going to click here. There is a small button. I'm pressing on this button here. This button says IBM Cloud Shell. It opens the shell that contains environment for me. So I'm going just to increase the size. It open my environment in the different environment. So in this environment, I don't like it, but let's see if I can connect to it. I should be able to connect. So I'm just going to connect via CLI, and we need to have the OpenShift. Get the OpenShift from the OpenShift console. We can get the token. So how to do it? We will get back to our environment here, and if I go to our environment under my name, there is a copy login command. So I'm going to copy login command here. Yeah, and I can display my token to this environment. So this is entire login command I'm going to use in order to connect to the cluster. So let me just copy it over, and I'm going to paste it in the Cloud Shell. So Cloud Shell, how to get to Cloud Shell when you are in your environment over here? You just want to be on the right account. So advo work, and then press on the small button over here. This small button opens up for you Cloud Shell, and then copy the OC link, supposed to open for you link. So if you write OC projects, you should get all the projects, and you are using the default project where we deployed our first app. And now following our instructions over here, so we can create our new you're using our own project. Yeah.
Could you, Sherry's asking if you can increase the size on your browser a little bit.
Yeah, I'm so sorry.
Oh no, I did the same.
Yeah, now you see that's the real problem. If somebody is not increasing the size, it's very hard to kind of follow. So I used OC project. Yeah, thank you so much for this comment. So so I'm using default project now. The default is one of those projects. Some others are just additional projects that are needed for such deployment. And now what to do next? So so first of all, I am going to work with the new application, and this new application is going to be using this entire script. And let me just get this. So I'm going to use GitHub repository. It's going to download from the GitHub to the context deployment. So deploying to OpenShift and name authors Git. So this is the we are using the deploying to OpenShift. So if you look for this application, it's going to be here, and -- name authors Git. So you will see the different app is going to start. And if we go to our topology, you will see right away there is a new app that is being deployed. So you see these authors that we deployed just a minute ago, and now this is the new one. So and we can watch how the application is running. So OC status, and the application is getting ready. So you will see on the topology, you will see more and more information. So it's building. It's a building stage. So let me just increase the size. So it's in building stage already, and we are waiting until it's going to be ready. So you have all the resources. You can kind of browse how the application is being built. And I don't need to create the YAML files for that. It's really just from the project that is being built, and we'll have this application. If you go to builds, as it's shown here, you will have it over here as well. So so that's the great thing, and the application. Our application is already here. So that's a great thing. We can see if we have any additional information, our builds. So application is running over here. So so that's a good sign. Now after it's running and the status is complete. So let's see OC status. It should be done, and now we are going to start the new. So we should see it, our application. So now we are going to add the service. So we are going to expose the service in order to get the root to our application. So if you look at our application, again, on the topology, you would see our Git application. This is our Git application, and it's running. And now we want to expose, because we don't have root, we want to expose the root. Yeah. So so let's get back over here. We want to use this command. So we want to expose service to the root, and so we are getting back over here to our Cloud Shell, OC expose service to authors Git. So the service is exposed, and now we can either look over here. So you will see the root is now available, or you can just use the command again, and you can just get the root to our service. So both ways work. So either this work, you will see this is the route to our service, or you can copy it from here. And if you click here, you will again get the server. And if you go to the end of it and open API/UI, you are going to see again the same screen. So the same service now deployed as a Git. So authors Git. So this part over here, let me increase the size. So you'll see authors Git. This is the second service that we deployed in a different way from GitHub directly to the cloud. And if you execute, you will see the response, and my colleague Niklas, an author of this lab. And that finishes the lab. You can play a little bit more. You have a source to image deployments. You can kind of play with that as well. As I said, as a stretch goal, please use this lab. I think the lab is here, and so you will be able to access your environment anytime on the after 24 hours. You can still access it, and you can follow the labs over here. They are on the left hand side. I'm sorry, it's very small. So what is OpenShift? A little bit of the introduction, and you will have some instructions on what to do. So step-by-step process. With that, I think let me see if there are any questions, because we can kind of wrap it up. Is it possible to run OpenShift locally on say Fedora VM on VMware? Yes, they are deployments that you can use OpenShift locally. It's like a kube deployment, and you can test it out. Please connect with me after on the Discord. We can kind of discuss the step-by-step process, but we can do it. And we are back with Bradston, kick Brad now. How it's going to stick, as I said, to us. So with that, you can find also some of the presentations that I was or blog post, and please follow us on the. So this is let me just. Yeah, Bradston is sharing the thank you page. So. I don't see any more questions. Then if you can run it on your own environment, but it requires a lot of RAM, and it's going to be kind of a load for the single environment. So with that,
just a quick thing. I know that I'll be done. I'm not sure if I'll done if you're still having issues, but he was having issues getting into the Slack. He wanted to join in. I'm not super, okay. I mean, I'm sorry, not Slack, Discord. I'm not super. Yeah,
the Discord. Yeah, I'm let me share once more the Discord link, so you guys can everybody can join us on the Discord. So that's one of the ways to kind of stay in touch. And usually, I am available every Friday and Monday from about 11 a.m. to 1 p.m. Pacific time. But feel free to kind of establish with me some time. And where is the Discord? So Aaron is asking where is this Discord. So I sent the Discord a link. Just click in the chat, and you should be able to join us. It's as I said, it's connecting to the book I wrote on serverless Swift. So if you want to learn a little bit about serverless and maybe try Swift, you can also use this space. This is the link to my book. I'm never fed up with sharing the link to my book. Because that's a cool thing to kind of brag about. But other than that, it's a space for everybody to kind of pick our brains. I've been myself in in the startup environment, in the enterprises. So I can really help you out. Just always is good to pick the brains. So Bradston, thank you very much for joining me today.
Yeah, thank you for having me, and you know, I encourage everybody to continue, you know, on this journey. I mean, there's so much to learn about, you know, Docker, Kubernetes, OpenShift. You know, definitely if you didn't get a chance to go through all the labs with us, go back to the link shared with all the lab materials and go back. You know, and take some time, you know, experiment, try, you know, new things. You know, that's how I learn a lot. And you know, feel free to follow us on Twitter. I shared our Twitters. We share like what we're doing, you know, different, you know, webinars that we, arigatou gozaimasu.
Yeah.
Those,
arigatou gozaimasu, yeah.
Yeah, you know, we share different things we're going on, you know, that different workshops. And, you know, I have a blog that I try to do weekly about different things. I'm excited about my upcoming one. It's going to be a little bit gaming centric, hopefully, in the future. So yeah, so check us out, and thanks for watching and participating.
Yeah, and I'm trying to post the link, but first of all, there is a survey for this workshop, so feel free to kind of give us feedback. These workshops, these webinars are for you. So so if you feel that we should spend more time on something other than we are spending now, or you'd like to know a little bit more, this is the way kind of to give us the feedback, and we would really try to kind of respond in the next workshops and themes that are for you. So Bradston, once more, King Bradston, King Brad, thank you very much for joining us. Everybody, thank you very much for joining, and the recording is going to be posted right away. So have a great day, great afternoon, great evening. See you soon.